Hello students, in this video we're going to look at question 1 part B on page 79. So it states that suppose the distribution of monthly phone bills is normal with a mean of 80, standard deviation of 9, and it wants us to find the smallest interval or range that contains 99% of the sample means. So let's write down what we know. We know that the average equals 80, standard deviation equals 9, sample size is 36, and if we were to draw this out, get a normal distribution, and we want to find the, well, first of all, the average being 80, we want to find the interval that contains 99% of all possible sample means. So the interval is going to be 99% of this distribution, going to be most of it, so let's draw it there. So this, from there to there, is 99%. It is divided by the mean, so the mean represents the middle value, so if we divide this 99% by 2, we get a value of 0.4950. What we're doing here is trying to find a z value that would represent both ends of that range. The z value is going to be based on an area of 0.4950. So we go to our normal distribution table, this table, and look for a value in the middle here of 0.4950. We're going to find it basically right in there. It doesn't show up exactly, but it is between those two values. We're going to pick 2.58. So our z value equals plus or minus 2.58. We have to remember that it's both plus and minus because it's going to be on the lower end, it's going to be negative 2.58. And on the upper end it's going to be positive 2.58. What we do now is apply our normal distribution formula for z. Remember that, let's write it over here, z equals sample mean minus a population mean over our standard error. And we are going to calculate the standard error before we calculate that interval. But before I do that, I need to move to a new page. So let's do that. The standard error, remember, is the standard deviation divided by the square root of the sample size. The standard deviation from the question is given as 9. The sample size is given as 36. So we need the square root of 36. So 9 divided by 6 equals 1.5. What we know in our z formula is we know the value of z. Z equals 2.58. What we are trying to calculate is the upper sample mean that would correspond to the upper value of this interval. So the sample mean minus the population mean of 80 divided by our standard error, which we have just calculated. So we know in this case, if we cross multiply, solve for the sample mean x bar, we get a sample mean of 83.87. We do the same thing for the lower value, but we apply a negative z value because that's on the left side of the distribution. So the formula on this is going to look the same. The only difference is the z value is negative. So the sample mean on the lower end of the distribution will be 76.13. This is stating that 99% of all the sample means should be within this range. Should be within this range between 76.13 in the lower amount, and 83.87 on the upper limit.